morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the string manipulation instructions of 8086 processor. The slides are prepared by referring the textbook Advanced Microprocessors and Peripherals, authors K.M. Budchandi and IARE, publication Tata Micro. Strings. A series of data bytes or data words in consecutive memory locations are referred as byte strings or word strings. For each byte string, it occupies one memory location. If it is word string, it is going to occupy two memory locations. For referring to a string, two parameters are required. One is start or end address of the string. If the start address is provided, the string instruction will be done executing from lower address to higher address. If end address is provided, the string manipulation instructions will execute from higher address to lower address. The second one is at the length of the string, which is usually stored in CX register or CL register, which will specify how many number of values or how many number of data bytes or words are present in the memory location. The 8086 processor supports a set of more powerful instructions for string manipulation. The incrementing or decrementing of the pointer depending upon the direction flag. For string manipulations, either the starting address or end address may be provided. The string manipulations will be carried out from lower address to higher address or higher address to lower address. For these two cases, the direction will be depend upon the direction flag of the flag register of 8086. If it is a byte string, the index registers are updated by 1 as it occupies one memory location. If it is a word string, the index pointers will be updated by 2 as each data will be occupied 2 memory locations. The count in both the cases, either direction flag is equivalent to 0 or 1, the count will be decremented by 1 for every data transaction for string manipulation instructions. The mnemonics associated with string manipulation instructions are given below. REP, move SB, move string byte, move SW, that is move string word, CMP SB, compare string byte or compare string word, CMP SW. Next SCASB, that is scan for a string byte, or SCASW, which is scan for a string word, LODSB, which is load a string byte, or LODSW, which is load a string word. And next instruction is STOSB, that is store a string byte, or STOSW, which is store a string word. The first instruction is REP. The REP is a prefix for a string manipulation instruction. The REP instruction is used as a prefix for other instructions. So if you have any string manipulation instruction, for this one we are going to be proceed with REP. The instruction prefixed with REP is executed repeatedly until the count specified in CX register becomes a 0. At each iteration, the CX is automatically decremented by 1. When the CX register contents are equivalent to 0, the execution proceeds to the next instruction in the sequence followed by the REP string manipulation instruction. The syntax of the instruction is REP string manipulation instruction. There are two more options for REP instruction. The first one is REPE or REPZ, which stands for repeat if equal or repeat if 0. The second one is REPNE or REPNZ, which is repeat operation will not equal or not 0. These operations are used for compare and scan string instructions only. The syntax of the instructions are REPE, the string manipulation instruction, or REPZ for the string manipulation instruction. The second one is REPNE for string manipulation instruction or REPNZ for the string manipulation instruction. The first instruction, which is for moving the data bytes or data words from one memory location to another memory location, that is move string byte, move SB, or move a string word, that is move SW. Move string byte or move string word. The move S instruction moves a string byte or string words which are pointed by DS:SI for the source string to the destination locations are which are pointed by ES:DI. The starting address of the source location is pointed by DS:SI and the starting address of the destination location is pointed by ES:DI. The same thing we can apply for whenever we are loading with the end address. Either the end address or starting address we have to load initially into the DS:SI and ES:DI. The REP instruction prefix is used with move S instruction to repeat it by the count specified in the CX register. The length of the string must be stored in the CX register. No flags are affected by these instructions. After move X instruction is executed once, the index registers, that is source index register SI or destination index register DI, are automatically updated and CX is decremented. The incrementing or decrementing of the pointers which are SI or DI depends upon the direction flag. If the direction flag is equivalent to 0, the index registers are incremented, otherwise they are decremented. The number of memory locations, whether incrementing or decrementing, will be depends upon whether the string byte or string word. If it is string byte, one memory location. If it is string word, it is for two memory location. For byte operations, the index registers are affected by 1, and for word operations, the index registers are affected by 2. Now we will see a small program for moving a strings of byte to move from 5000 location in the data segment with the offset value 1000H to the target location, which is having the segment address is 6000H and offset is 2000H. The values of the source segment register and extra segment registers we have to move with the 5000 and 6000 respectively. So for that, move AX, 5000H, and this AX contents will be loaded into DX register. These two instructions are pointing to the data segment register DS. Next, move AX, 6000H, move ES, AX. These two instructions are for loading the extra segment with the address of 6000H. The number of memory locations which we are moving is 9. So for that we are taking into CX register with the move instruction. Move CX, 09H. The offset value we are going to be load into the SI and DI respectively for data segment and extra segment. Move SI, 1000H. Move DI, 2000H. For string manipulation instructions from lower address to higher address, we have to clear the direction flag, that is CLD. Next, move SB. Move XB will move the data which is present at 5000:1000 to 6000:1000. If you want to move multiple data, we have to execute this move instruction repeatedly. So this instruction will be prefixed by REP instruction. The next instruction is compare string byte or compare string word. The CMPS instruction can be used to compare two strings of bytes or words. The length of the string must be stored in CX register. If both the strings are equal, then the zero flag will be set. After each iteration, that is after each comparison, the index registers are updated depending upon the direction flag, and the count in the CX register is decremented by 1. This byte by byte or word by word comparison continues until a mismatch is found or the count is equivalent to 0. When a mismatch is found, the carry flag and zero flags are modified appropriately and the execution proceed further. Program for comparing two strings. The source string is pointed by the segment address 1 followed by the offset value str1 with the other string which is placed in the extra segment with the segment address is scg2 and the offset is str2. The segment address of data segment scg1 will be loaded into data segment register ds, and the extra segment address, that is scg2, will be loaded into the es register by moving the data into ax register followed by ax contents moving into the segment registers. For moving the segment 1 address into the data segment register, the instructions which we require is move ax comma segment 1, move ds comma ax. These two instructions are used for loading the segment address of the data segment into ds register. Next, for loading segment register 2 content into the extra segment registers, we are going to execute two instructions by moving into AX from AX to ES. Move AX comma segment 2 followed by move ES comma AX. So these two instructions are used for loading the segment address of the extra segment into the ES register. Next, how many string bytes or string words we are manipulating, that we are going to be loaded into the count which is CX register. Move CX comma 09H. In this example, we are taking the string are 9 in number. Next, move the offset value into the SI and DI respectively for data segment and extra segment. Move SI comma offset of string 1. Move DI comma offset of string 2. For manipulating the instructions from lower address to higher address, clear the direction flag by using the CLD instruction. Then the compare will be done for these strings by using the instruction CMP SW, because here we are considering the string words CMP SW. So when we use the CMP SW, it will check the first string byte of source string will with the destination string. The comparison will be takes place if the first elements are equal. So for that we are going to be use a prefix, that is repeat if equal. If the first string are equal, that is string 1 and string 2 which are pointed with the offset values, if these two are equal, proceed for further for comparison. If any mismatch is there, one of the element of source string is not equivalent to the destination string, in that case it will terminate the loop. The next instruction is SCASB or SCASW, which is scan string byte or string word. The SCAS instruction scans a string bytes or string words for an operand byte or word specified in AL or AX register. The string is pointed with extra segment and index register DI. The source is present either it is in AL register or AX register. The length of the string for comparison we are going to be stored into the CX register. When a mismatch is found, then the execution stops and Z flag is equivalent to 1. If no match is found, the zero flag is reset. That is, Z flag is equivalent to 0. The REP-NE prefix is used with SCAS instruction. The pointers and counters are updated automatically till a match is found as we are scanning for a string. First, the element which are present in AL or AX will be compared with the first string of destination target which is pointed with ES:DI. If these two are not equal, then it is proceed for comparing next string, comparing next string, comparing next string, like this till end. At any point, if the match is found, then the execution will be stops. Program to search a string byte or string word from a segment address which are having loaded with the SCG and offset is STR. This segment address and offset values are loaded into ES:DI register pair. First, move AX, segment address, followed by move ES, AX. These two instructions are used for loading the segment address into the extra segment register. The number of elements in the string will be copied into the CX register by using move CX, 09H. The offset value of the string is loaded into the DI register with the move instruction, that is move DI, offset of the string. The search word or byte we have to load into AL or AX register. In this example, we are searching for a byte, so we are going to be loaded into AX register with the instruction move AX, search word. For processing the string from lower address to higher address, clear the direction flag, that is CLD. Next, scan for a string using SCASW. Here, the repetition of scan will be takes place if the scanned element which is present in AL or AX register is not found in the memory location which are pointed with ES:DI. If these two elements are not matched, then it will be proceed for further for scanning. So that's why here it will be prefixed with REP-NE, which is repeat if not equal. The scan will be repeated only if they are not equal. So whenever it is equal, the condition fails, it will come out of the loop. For all the cases, if I have 5 elements in this string, if AL or AX contents are not found in this particular memory locations, then it will be proceeded till CX is equivalent to 0. The next instruction is LODSP or LOSW, which is load a string byte or string word. The LODS instruction loads a string byte or string word specified in AL or AX register by the contents of the string pointed by DS:SI register. So whatever the string which is pointed with the DS:SI, this will be copied into AL register or AX register depending upon either it is string byte or string word. The length of the string must be stored in the CX register. If the byte transferred, the CS is modified by 1. And if it is word transfer, then it is SI will be modified by 2. No other flags are affected by this instruction. The SI is modified automatically depending upon the direction flag. Small program for loading a string byte into the AL or AX register. Move AX, segment address will be loaded into DS by using the instruction move DS, AX. The offset value will be stored in ASI register by using the instruction move SI, offset of string. For starting address to the end address, clear the direction flag by using CLD instruction. Then for loading the string byte into AL or AX register, use LODSB. The last instruction of the string manipulation instruction is STOSP or STOSW, which is store a string byte or string word. The STOS instruction stored a string byte or word specified by AL or AX register for byte or word into the location which is pointed by ES::DI. So the contents of AL register or AX register will be copied into the memory location which is pointed by ES:DI. The length of this string must be stored in CX register. If it is a byte transfer, then DI is modified by 1, and if it is a word transfer, then DI is modified by 2. No other flags are affected by this instruction. The DI modification automatically depending upon the direction flag. A small program for storing a string. The offset value and segment address will be loaded into ES and DI registers. Move AX, segment address. Move ES, AX. These two instructions for loading the segment address into extra segment register. Offset value will be stored into DI register by using move DI, offset of string. Next, move AX, store word. The string byte or word which we want to load, that we have to load into AL or AX register. In this example, we are storing a string word, so we are loading into AX register. For processing the string, in lower address to higher address, that is starting address to end address, clear the direction flag by using CLD instruction. For storing the string word, use the instruction STOSW. So when this instruction is executed, the AL or AX contents, as it is a string word, AX contents will be loaded into the segment register segment address which is pointed by ES:DI. Thank you all. So in this class, we have discussed the various string manipulation instructions. Before starting the string manipulation instructions, first we have to load the starting address or end address of the string. For source string, we have to load into DS:SI. For destination, we have to load into ES:DI. This is first step. The second one is the length of the string. How many string elements we are processing, that count we have to load into CX register. The third step is we have to clear or set the direction flag depending upon either to be processed from starting address to end address or end address to starting address. So here update the direction flag either to 1 or 0. After updating the direction flag, then the string manipulation instruction can be executed. These are the steps we have to follow. The various instructions which we have studied is REP, which is for repetition of execution of a string manipulation instruction. There are two more flavors. One is REPE or REPZ, repeat if equal or repeat if 0. So this instruction is used whenever the Z flag is equivalent to 1, it will be repeated. Otherwise, the loop will be terminated. The second flavor is REPNE or REPNZ, which stands for repeat if not equal or repeat if non-zero. The condition which you are going to check is if Z flag is equivalent to 0, then the repetition will be takes place. Under string manipulation instructions, we have studied move SB or move SW, which is move a string byte or move a string word. Then compare string byte by using CMPSB or CMPSW. Then scan for a string by using SCASB or SCASW. Scan for a string byte or scan for a string word. Load a string byte or load a string word by using LODSB or LODSW. Store a string byte or a store string word by using STOSB or STOSW. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.